Compounding interest. Build a function to compute compound interest giving a starting amount P, an annual interest rate R, the number of compounding periods N, and the total number of years. Okay, so that's a lot of information there, but okay, I've already got a script ready to go and my interpreter open up, and I know I'm going to need a function, so def comp int, and we needed a starting amount P, an interest rate R. I'm going to make that a lowercase p, R, compounding periods and years. What was that? T, I think. Okay, there's a lot going on here, and it might be challenging to do this all in one go. So I think I'm going to, you know what, for first things first, return P, right? Let's just make sure our function does this. So run 5.3. Okay, let's run comp int, and let's give it I don't know, let's say $40, and then I don't know, 25%, and then I don't know, like 2 and 1 10 years. I don't know, that they don't really matter for now. Let's just make sure our function can actually return P, because if that works, that's a good first step. So that worked. That's good. I'd hope so. So, okay, next things, let's try to remember, right, if I want to calculate a percent of something, I just multiply it by the percent. So, times R. And let's reload our script and run the thing again. So 25% of 40 is 10. Okay, that worked too. But this is, of course, not what we want, because that's only what 25% is. This is compounding, so this should be on top of the principal, the piece. So it should be actually times 1 plus R, right? Let's just reload that script, make sure that works. So this should be a total of 50, I think. Okay, that worked, good. Okay, and now I'm trying to remember, is there... let's forget compounding periods for now. I'm trying to think, what if I need to do this over so many years, how do I, right, it's exponent, right? If I want to do multiple multiplications, just an exponent, right? So to the power of t, right? Because if it's going to be doing it for 10 years, which I'm passing it, I want to do that 1 plus r times p like 10 times. So let's reload our script, make sure that works. Okay, well that didn't seem to work. That's because I didn't save it. Let's reload the script now, see if it works. Okay, I'll assume this works. I'll take that number as hopefully being correct. But you know what, I really can't remember the compounding period thing right now, so I'm going to go back to the internet and do a quick little search here. Now, let's see if Google can tell us. Okay, Wikipedia, I've got hopes for Wiki. Oh, there we go. So it's P times 1 plus R over N to the power of N times T. Ah, we were close. We were very close. So I'm just gonna incorporate what I just learned back into our script. So this is actually R divided by N, and then it's N times T. Okay, and let's reload the script, hit run. Okay, great. Okay, good. It really seemed to work. So this is really exciting. I guess I'm just going to type this into an online compounding interest calculator just to make sure I'm not crazy. Tick-tock. Okay, I said, what was it? 40, 25 additional, okay, 0 years to grow, 10 interest rate. I put in 25%, which is outrageously high. Calculate 421. And I believe that's what I put in. So it works.